Okay, so we have lots of these problems where you're dealing with a rectangle, and what we're told is that the width is 3 less than twice the length x. So the length is x, and the width is 3 less than twice x. So set that up. And the area is 43 square feet, which equation can be used to solve the length. So we multiply these two, x times, sorry, where did I write this? To find area, you multiply the width by length. So x times 2x minus 3, and that equals 43. If you proceeded from here, you could solve for x. So choice 4 allows us to do that. Okay, so we want to write this in simplest form. So essentially we have these two quadratics. We want to factor both of them. In the numerator, we have this quadratic, x squared minus x minus 6. To factor that, what we most likely do as a starting point is find factors of negative 6, the last number here, the last term that adds up to the coefficient of the second term, negative 1. So what factors of negative 6 add to negative 1? Well, I know that negative 3 times 2 is negative 6. If I add those two numbers, negative 3 and 2, I get negative 1. So I'm going to use those two, negative 3 and negative 2, or positive 2. So again, those two numbers multiplied are negative 6, added are negative 1. Those are the numbers we're looking for. So that's a quick way of factoring it. That's our numerator. In the denominator, what do we have? Well, in the denominator we have x squared minus 5x plus 6. So now we're trying to find numbers that are factors of 6, but add to negative 5. So I know 6 times 1 is 6, but I also know negative 6 times negative 1 is, positive 6. And that would add to negative 7, so it doesn't help us, so I'm going to use 2 and 3. Negative 2 times negative 3 is positive 6, but added together are negative 5. So that's our factored form. Just throw the x's in there. So now we bring this together, and what we have is a fraction that will reduce. Numerator, x minus 3 times x plus 2. Denominator, x minus 2 times x minus 3. And what cancels out nicely are the x minus 3's. Let's cancel out. We have x plus 2 over x minus 2, choice 1. Okay, here they want to solve for x. We have x plus 2 over 6 equals 3 times x minus 1. We'll multiply both sides by 6 to start off. These cancel out. X plus 2 equals 18 over x minus 1. Next, I want to get my x minus 1 out of the denominator. Multiply both sides by x minus 1. On the right-hand side, these cancel out. On the left-hand side, we start to form a quadratic. X minus 1 times x plus 2, right? So x times x is x squared. X times 2 is 2x, and then negative 1 times x is negative x, so 2x and negative x, that's 1x, or plus x. And then negative 1 times 2 is negative 2. So we did all that, and that's going to equal 18, right? The number we have here. So we're going to solve for x, though. So we're going to subtract 18 from both sides. And what this will allow us to do is set the equation equal to 0. X squared plus x minus 2 minus 18 is minus 20. That equals 0. So now the question becomes, how can we factor this, right? We want to find what x is. So we have x squared plus x minus 20, and that equals 0. What factors of negative 20 multiply to get negative 20 but add to positive 1? Remember, you're looking for factors that add to this number that multiply to negative 20 but add to this number here. Don't forget that 4 and 5 multiplied to 20. So we're going to use 4 and 5, and we want it to be positive. So we use positive 5, negative 4. Multiply those two numbers. You get negative 20. Add them, you get 1. So now this equals 0. And remember the logic here is that, well, we have these two numbers, 1, 2. We're multiplying them to get 0. So if that's the case, then either they're both 0 or one of them is 0. Let's assume they're both 0 and solve for x. X plus 5 could equal 0. In that case, we subtract 5 from both sides, and x equals negative 5, our first solution. Or x minus 4 could equal 0. Add 4 to both sides, and x equals 4. And there we have the two values that x could equal. Which values, for which values of x is this algebraic expression undefined? So remember that undefined means that the denominator would equal 0. So this quadratic right here, we want to know when would it equal 0, what x values. Well, when would it equal 0? Let's factor it. Put our x's in here. And now we're trying to find factors of negative 12 that add a negative 4. So I know that 6 times 2 is 12. That's perfect. Negative 6 times positive 2 is negative 12. Add them up, we get negative 4, and we're done. So now we can solve. Remember, we're trying to figure out what values of x would make this denominator 0. So if we multiply these two, we're saying we will get 0. So one of them is 0, right? Or both of them. Let's say x minus 6 equals 0. Add 6, you get x equals 6. So if x is 6, the denominator is undefined. Second number, x plus 2 equals 0. Well then, x equals negative 2. If x is that number, the whole expression will be 0, and the whole fraction here will be undefined. So our two choices are negative 2 and 6. For both those values, the denominator and function would be undefined. Okay, here they want us to solve algebraically. We have 3 over 4 equals negative times x plus 11 over 4x plus 1 over 2x. Okay, well, here, 1 over 2x, we can change that by doubling the numerator and denominator to 2 over 4x. And now we can add that to this term over here, which is negative x minus 11. Negative x minus 11 plus 2 all over 4x equals 3/4. Okay, well here, negative 11 plus 2, that equals negative 9, right? So negative 9 over 4x. I'm going to multiply both sides by 4x as well to get rid of the 4x in the denominator. It cancels out. The 4's will cancel out here, and we have 3x left over. So 3x equals minus x minus 9. But you want to know what x equals, so we add x and 9 back to the left-hand side so we can get 0. It's usually a good idea to get 0 on one side of your equation when you're solving for a quadratic. Now we'll go up here. Sorry, running out of room. Here we added x to the left, right? Sorry, though, I realize this is not actually a quadratic, right? Because here, for some reason, I was saying quadratic. I don't see anything x squared. So instead of adding 9 back over, I'm just going to add x. So we get 4x, right, equals negative 9. Divide both sides by 4, and x equals negative 9 over 4. And that's our answer. We plug it in, and we'll see that it's true. Let's just try it because I'm feeling a little nervous about this one now. So you have negative 9 over 4. So does 3/4 equal negative 9 over 4, so plus 9/4, plus 11, that's 44/4, over 4 times negative 9/4, plus 1 over 2 times negative 9/4. Okay, this looks a lot worse than it really is. Here, the 4's will cancel out. Here, this 2 and 4 kind of cancel out, you get negative 9 over 2. So now it's a little bit simpler, right? Here we get 9 and 44, but I made a mistake. It should be minus x minus 11, right? So here it should be minus 44 over 4. So we have 9/4 minus 44 over 4. I'm going to think of that as, take 9 away, right? From 9, you get 0, and that you're taking 44 away, so you have 35 left to go, so it's negative 35 over 4. So negative 35 over 4, right? And that's over what? Over negative 9 plus 1 over negative 9/2. So clearly this is not a very friendly problem, but we can deal with it. 1 divided by negative 9/2, multiplied by the reciprocal, is negative 2/9. Here, divided by 9, I'm going to multiply by the reciprocal and get negative 35 over 4 times 9, but negative 9 really, so it's going to be plus, right? And then that's going to be 36. So we have 35 36 minus 2 ninths. We can scale up 2 ninths by 4 to get 8 36. So take 8 from 35. What do we get? 27 36, and that is 3/4. So we got the right answer, even though it took us a long time to check it. Okay. Okay, we don't know which expression is equivalent to the one we're given here. So we're given 2x to the 6th minus 8x to the 4th plus 2x squared all over 2x squared. So since we're dividing by 2x squared, we really want to divide each term by 2x squared over and over again. So the first one, 2x to the 6th over 2x squared, that's just x to the 4th. Then negative 18 x to the 4th over 2x squared, that's just minus 9x squared. All I'm doing for each of these, I divide the numbers, 2 by 2 is 1, and then divide the exponents here by subtracting them. Remember that rule, if you have x to the n divided by x to the m, that equals x to the n minus m. I'll apply that rule right here, amongst others. So negative 19 over 2 is negative 9, x to the 4th of x squared is x to the 2nd, and then 2 divided by 2 is 1, x squared divided by x squared is 1, so it's plus 1. Okay, so that gives us an answer. We have choice number 4. Express the product in simplest form. So before you start multiplying or going crazy with any of these questions, factor out and use the distributive property. 4x plus 20, factor out the 4, it's 4 times x plus 5. In the denominator here, we have x squared plus 6x plus 8. What factors of 8 add to 6? Right? That's the question you want to ask. That's 4 and 2. So x plus 4 times x plus 2. Right? So here, we're almost ready to finish. This and this cancel out. We're multiplying them in the end anyway. And here, I don't see anything that cancels out except for the 4 and the 2, which is just 4 divided by 2 is 2. So we have 2 times x plus 5 over x plus 4. I think that would be acceptable. For which values of x is the fraction undefined? So all you're doing at this point is finding values that make the denominator equal to 0, because if this denominator is 0, so if this is 0, then your answer is undefined. So factor it out. We have x squared plus 5x minus 6. If that equals 0, what x value would do would cause us to be undefined. So we have our x's here, and to find the two other numbers that go, I think, what are the two factors of negative 6 that add up to positive 5? I think we're in a way of positive 6 times negative 1. Multiply them, we get negative 6. Add them, you do get 5. So it's not 6 though, and it's not negative 1. Remember, this equals 0. So x plus 6 could equal 0, and x minus 1 could equal 0. Solve for x, and those are the values that you're looking for, negative 6 and 1. Choice 1. Express this in simplest form. We have a difference of perfect squares in the numerator. So x squared minus 1 becomes x plus 1 times x minus 1. Remember, a difference of two squares literally means difference, or subtract the two squares that you're given, take the square root of each, and that's how you factor them. I factored x squared into x, and I factored 1 into 1. So we get x plus 1 times x minus 1. And that'll help us cancel out in a moment. In the denominator, we have x squared plus 3x plus 2. What factors of 2 add to 3? We'll just try x plus 2 times x plus 1. The factors 2 and 1 multiply to 2 and add to 3. So that works. We have x plus 2 times x plus 1. The x plus 1's cancel out, and we're left with x minus 1 over x plus 2. Okay. Which expression represents this in simplest form? Notice we have x squared minus 25 here. That's a difference of two squares. So x squared is a square and 25 is a square. The difference, though, is found so easily. We just basically add and subtract the two square roots of these two perfect squares. So here, that will be your new denominator here. And in the numerator, we have something slightly more complex. It's x squared minus 3x minus 10. What factors of negative 10 add up to negative 3? Well, I would say negative 5 and 2, right? Because x minus 5, or using negative 5, and then x plus 2. If you multiply negative 5 and 2, you get negative 10. If you add them, you get negative 3. We're done. So here, we do a little bit of canceling out. The x minus 5's cancel out. We're left with the answer x plus 2 over x plus 5. Choice 2. Okay, we want to factor this completely. That just means, factor, but usually when you get something nasty like this, right, and it starts in a higher exponent than 2, because this is our beginner problems, we want to factor out enough to get this reduced down to x squared. So if it's at x to the third, a common factor should be x or x squared. So here we're going to pull out x out of all of these, which is fine, hopefully, because you have umbrellas, and the 3, because 3 is the common link between 3, 33, and 90. So you pull out 3x, and then if we had to redistribute, you can see that it should be x squared minus 11x plus 30. Did we get it there? Yes, okay. So now, it's just a matter, oh, well, it looks like we're done. Sorry. Choice 2 finishes that off nicely. But let's just factor it further. What factors of 30 add up to negative 11? Well, I know that if I multiply negative 5 and negative 6, right? So we have x minus 5 times x minus 6. If I multiply negative 5 and negative 6, I get plus 30. If I add them, I get negative 11. So that could work. So we have 3x, x minus 5, and x minus 6. So here I shouldn't have circled choice 2. It wasn't factored completely. I missed that prompt right there. Choice 4 is a completed factored form. And okay, thank you.